Caltrans is combining two innovations to improve bridge project delivery. The first is a new class of cementitious material called ultra-high performance concrete, or UHPC. And the second is a method of constructing bridges faster with fewer construction-related impacts called accelerated bridge construction, or ABC. UHPC has performance characteristics that far exceed conventional concrete. A combination of strength, ductility, durability, flow properties, and strong bonding to rebar and precast concrete surfaces make UHPC a material that can be effectively applied to bridge projects in a variety of ways. The unique properties of UHPC are achieved through a combination of finely ground constituents, a low water-to-cement ratio, needle-like high-strength steel fibers, and plasticizers. The gradation and composition of these materials allow for the optimization of particle packing. The dense packing of particles means the material is stronger, lasts longer, and helps it flow into tight spaces while fluid. The addition of steel fibers provides ductility or tensile capacity not seen in conventional concrete. The fibers also control cracking and provide confinement that reduces the amount of reinforcing bars required in a design. The flow properties of UHPC allow it to completely fill small joints and create intricate shapes. UHPC properties open up new options to improve and advance bridge construction. Superior strength, flow, and durability have led to a host of innovations. This footbridge in Japan illustrates how UHPC bridges can be built with lightweight sections to provide a slender aesthetic. When used to connect precast elements, UHPC joints are smaller with less rebar and easier to construct. Since the material flows easily through complicated forms, intricate shapes can be created for stunning results. And the durability of UHPC provides a robust material that can be used in harsh environments that last for a very long time. UHPC is used worldwide. European and Asian countries have used UHPC as a structural material to build long, slender bridges. These projects take advantage of the lightness, simple execution, architectural appeal, and versatility that UHPC offers to create iconic structures. UHPC resulted in lighter loads that allowed for a longer span length on the footbridge of Peace in South Korea. This UHPC structure, also in South Korea, serves as the standout access bridge to a new Legoland under construction. This museum in France used UHPC to construct intricate lacework panels for the building, and to construct a long, slender pedestrian bridge made entirely of prefabricated UHPC sections. The precast U-shaped bridge sections are connected through post-tensioning steel. A very unique aspect of the bridge design is that it did not require any reinforcing steel beyond the UHPC fibers and post-tensioning strand. UHPC has other unique applications such as roof canopies and even furniture. Switzerland has focused its use of UHPC on bridge deck rehabilitation. The addition of a layer of UHPC enhances the strength and durability of the existing reinforced concrete deck of the Chillon Viaduct. In 2013, two parallel 1.4-mile-long structures received a UHPC overlay in a single summer season. This overlay effectively waterproofed the deck to prevent future damage in severe environmental conditions while enhancing structural resistance. This rehabilitation technology has been well proven and accepted in Switzerland. Caltrans is currently funding research to apply this technology to our large inventory of aging bridge decks across the state. The United States has seen over 200 UHPC bridge projects to date. The overwhelming majority of applications are UHPC connections of prefabricated bridge components. A popular practice on the East Coast is to construct new decks with prefabricated deck elements connected with UHPC joints. The prefabricated sections of deck are set by crane for quick assembly, and the joints between the precast deck elements are filled with UHPC to provide strong, durable, and simple connections. UHPC is also used to connect entire superstructure sections, such as the precast adjacent box beams shown here. The keyways to connect the precast beams have a simple layout of short lat spliced rebar. The keyways are filled with UHPC to provide a joint that connects the pieces of the bridge resulting in a robust structural system. The practice of fabricating pieces of a bridge off-site and then quickly assembling them at the bridge location is one method of a type of bridge construction called accelerated bridge construction, or ABC. In this example of an ABC project in District 2, the precast components for the bridge were fabricated off-site at a precast facility, trucked to the bridge location, where the components were placed with a crane, and connected with post-tensioning and cast-in-place closure pours. A steel prefabricated rail was attached in 6 hours. From the time the piles went into the ground, the bridge was built in just 23 days. Accelerated bridge construction, or ABC, can be described as a type of construction that uses innovative methods and materials to build a bridge quickly while minimizing construction-related impacts typically associated with conventional construction. There are several methods of ABC, including launching a bridge across an obstacle, driving it into place, or sliding it into its permanent alignment. The most common method by far is prefabricated construction. This type of construction has many advantages. They include improved safety for workers and the public, better environmental outcomes, less congestion, easier construction, and better value for the public. The innovations of UHPC and ABC have come together in California to develop seismically robust connections for our prefabricated bridges. Caltrans has done extensive research to determine the best way to build seismically robust joints to create a prefabricated bridge that will behave well in an earthquake. One of these research projects illustrated the effectiveness of UHPC as a joint material to connect columns to other portions of the bridge. This research was deployed through pilot projects to allow us to learn the best way to implement UHPC in our bridges. The first project was the Laurel Street Overcrossing in District 4 near Vallejo. Precast columns were set in place, and then the precast cap was threaded over the columns in a single night. The rebar extending out of the columns were threaded through individual voids in the bent cap. Those voids were filled with UHPC to create a robust connection. Prior to placing the UHPC in the field, we had the contractor practice his means and methods on a mock-up. Then we cut the mock-up open to make sure that the UHPC had filled all of the voids for a strong connection. A similar project was built the next year in District 10. Both projects yielded valuable information on the best way to go forward with future UHPC projects. Caltrans has gone on to use UHPC to connect superstructure sections together. One of our first projects of this kind has just been completed at Echo Summit in District 3. A similar project was built the next year in District 6. Both projects yielded valuable information on the best way to go forward with future UHPC projects. Caltrans continues to add to its accelerated bridge construction inventory thanks to the spirit of embracing innovation in bridge project delivery. We have several more accelerated bridge construction, ultra-high-performance concrete projects in the works to provide quality bridges while improving safety and minimizing disruption to both the public and our environment in California. To learn more about accelerated bridge construction and ultra-high-performance concrete, please visit the Division of Engineering Services ABC intranet website.